Okay guys, in this tutorial what we're going to do is we're going to go ahead and we're going to make a motorized pinwheel. Now you'll notice there's some new things here. If you look at our parts, we have a MOSFET, we have a diode. So there's some, here, let's take a look at the parts. So we have a diode, we have a MOSFET, you have a motor, you have a switch, battery snap. So there's a couple things here we haven't used. This one we sort of tried to use at the beginning of the year, but it just didn't work out that well. So let's take a look. So if we have all this, transistors, we talked about this, they're components that allow you to control high current and voltage through a power source of a low current. So basically, it's a proxy between our battery and our Arduino, because the Arduino can't power a motor directly. It'll actually blow out its port because it will draw too much current. Okay, so that's why you use this MOSFET. That's what that will do. And if you're wondering why this transistor, like this one, is plastic, and this one is plastic too, but it has this little metal piece, what this little metal piece does is it cools it. It takes the heat away. Okay? Let's see. Okay, so what this is saying is, when this motor turns, right, it's turning, it's turning, it's turning, it's turning. When it stops, a lot of the power will actually shoot back into the Arduino, go boom, right back into the port. So what this diode does, it's like a light emitting diode, same kind of thing. It's just not a light emitting diode, it's a regular diode. What it does is this piece is really important to understand what this does. This only makes electricity go one way. So once it comes back in here, it'll go poof, it'll discharge its electricity. It'll actually stop here because the electricity cannot go across this diode. So this diode is preventing, if you follow this route, you'll notice that it will go into port 9. If you don't add this diode, you could potentially blow out your port 9 or blow out your entire Arduino board. And now if you have a $20 Arduino, that sucks. You just ruined your Arduino. So we don't want to do that, right? We want to prevent that from happening. So if you look, you'll see your diode right there. This is how this schematic looks. It's actually a lot easier to look at it here. So let's go ahead and wire this thing up, and then we'll code it. The code's really easy. So this isn't too much about code this week. It'll be real light with the code. The activity, I'm just going to ask you a few questions. This is going to be a quick week. Next week's going to be harder because we're going to go over something called an H-bridge, and that's a motor driver. That's really, really, really cool. You could actually make robotic cars and stuff with that chip. The chip's cheap too. You just have to make a little circuit board for yourself. So let's go ahead and make this. I'm just going to go ahead and put this over on my mother monitor. All right, so what we need is a breadboard. Okay. We need an Arduino. We need a diode. Just a regular diode. These are actually like the same thing, the same technology. An LED and a regular diode have the same technology, except one emits some light when electricity goes through it. That's the only difference. It's basically the same thing. You need a button. No, I don't want to call this diode. Unfortunately, you can't use a potentiometer for this. It won't work, okay? We need a MOSFET. It could be a PNP or NPN. It doesn't matter. I think the one they're using in the book is an NMOS. So let's see. Let me just make sure. You have DGS. Let's see. That should do it. All right. We'll just have to hook this up. I'm not sure which one's going to go to which here. We'll have to take a look. All right, so let's go ahead and just rotate this thing. Okay. What else do we need here? I'll explain what's going on there in a minute. You need a 9-volt battery. Okay, we need that. All right, let's go ahead and rotate that. Awesome. We need a resistor. Let's see. You need a 10K resistor, so let's get one. All right, that's our 10K resistor. I think we're good. All right, let's go ahead and hook this thing up. So what we'll do is let's start out with the Arduino. Let's take the 5-volt. And let's take the ground. All right, that's that. Let's go ahead and take our switch. Now remember, this is the wrong way. We have to go ahead and do that. We have to make sure that's terminal 1A, terminal 2A. That's the way we need that. Otherwise, it won't work. You can make this red if you want. It's kind of neat. You can make this one black. Okay, and then we're going to do this to here. We're going to make this red. Excuse me. All right. We're going to do the button a little bit different than the book's doing it. So we're going to go to 2. We're going to use the cool feature in the Arduino of the input pull-up, so we don't have to worry about a resistor. Because just so you guys know, all of these in here have resistors built in, which makes it really easy for you to go ahead and do your thing. So without an external resistor, so you don't really need one. All right. And okay, that should be good. So if we're going to do this right here, this one could actually be ground. All right. If you're not sure, like, hey, did I hook this thing up right? If you're not sure, what we could do is we could test it. Let's do a quick test. All right. Let's go to code. And we want text. Say continue. And we'll go ahead and input. Let's do 2. And we want that to be input underscore pull up. And now all we want to do is this. Serial.begin 9600. That'll start our serial monitor. Excuse me. And then what we'll do is this. We'll say int button state equals let's see here. Digital read 2. All right, and then we'll say serial dot write dot print ln. All right, so then we'll go ahead and do this. All right, very good. And Excuse me. Let's run the simulation. Okay, so if we click on it, we notice it's 0. If we lift it up, it's 1, 0, 1, stop. Okay, so that's how you could quickly test it. We'll close the code now. So we know our button's hooked up, right? So that's good. All right, let's move on. So we're going to take the MOSFET, which was somewhere. I guess I didn't get it. Where did I put it? Under there? No? All right, let's bring it back. All right. And we're going to take the MOSFET and we're going to put it over here. Okay, and the way you do these, if this was real life, the tab, the metal tab, there's like a lip here. And the lip will be, it's 3D. You can see it better here. You can see it better there. And the tab's facing away from you. That's how you use these. Well, you don't have to, but that's how we're using it. So we're just going to go ahead and go to pin 9. This is going to go to the gate. The ground is going to go to the ground. And then the drain. Let's go ahead and grab this. So I'm going to go right up to here. And then this drain is going to go up to here. Okay? We need a motor. Can't forget that. It's kind of the point of what we're doing here. All right. Any of these motors will do. This is cool. This is a motor with an encoder. I actually don't know how to use this. I need to look this up. I'm not sure how to use these. All right, so that's the motor. Okay, cool. All right. Let's go ahead and put the motor over here. And the battery is here. I'm just going to do this to make our life easy. All right. Okay, so that's that. We have our motor. We don't need the resistor. You can get rid of that. Then we're going to have our motor. So the hot to the motor is going to go to the battery. And then this is going to do something interesting. Excuse me. This is actually going to go right here. This is in the wrong spot. This has to go right here. So what's going to happen is when you press this button, we're going to send a signal from the Arduino over to this MOSFET, and then this MOSFET is going to drain. It's going to drain and send the signal over here to turn the motor on. That's what's going on. And again, the reason why we need this diode, let's make this red. The reason why we need this diode is to protect our Arduino. Let's make this black. So it's pretty nice if you actually color your wires. You don't have to, but it makes your life easy. All right. And what you might want to do is everything going to the Arduino could be yellow. All right. This looks better. Let's make this yellow too. And let's make this black. All right, so everything's nice and done here. The code is really simple, so let's take a look at the code. All right, so here's the code. This is what we do. We're going to come up here, and we're going to go to const int switch pin equals 2, const int motor pin equals, let's see, it should be 9. Int switch state equals 0. Okay, so that's just setting up our variables. Let's go ahead and do our pin modes. Instead of putting this at 2, we're going to actually use this as switch pin. And the other one, we're going to do motor pin. And that's going to be output. Okay, very good. All right. Let's go ahead and go in our loop stuff. Now we're going to say switch state equals digital read switch pin. So that's going to read either, what do you call it, 1 or 0. If, excuse me, switch state is equal to high, digital write, motor pin, high, else, excuse me, digital write, motor pin, low. All right. Okay, guys, I made one error here. So if you look, let's split our screens like this. Where are we? Right here. That the anode has to be over here, and the cathode has to be connected to the power area. Unfortunately, it doesn't look like the Arduino. The simulator actually runs right. It just, for some reason, it just won't run this motor. I think it's a limitation of the simulator. I don't think they have those simulating correctly, because if we look at this circuit, we can just sort of analyze this for a second. Let's see if we could snap it here. All right. And let me close this. Let me close this. See if we can snap this. Okay? Beautiful. So if we look here, and we look at all the little bits and pieces here, we have the ground to 5 volt, so we look at ours. 5 volt ground. And we look over here. Okay? That's good. That's good. Then we have the power to the switch. This doesn't really matter. Which way we do it, this doesn't matter. So ours is slightly different here, but the switch works because when we start the simulation and we test it, let's see here. If we go to code, start simulation, see, it works. It's saying hello. And then if I come over here and press the button, it's now saying bye. So it's registering. So that's how we know we're good. Okay, so the button's good. Now we look at the MOSFET. So the 9 goes over to the left. So we have pin 9, it goes over to the left, which is the gate. We're good. Then the drain goes to here. Okay, we're good. And then the ground goes over to the source. So the ground to the source. Beautiful. Okay, now let's look at this. Okay, I forgot one thing. So what I didn't do is this ground has to go over to this ground. I don't know if this probably is the one that matters. Let's see. Yep. Okay, good. Let's see what else. Anything else I may have missed. So this should be the black wire. All right, so this is how I troubleshoot. So kind of a real-time troubleshooting session. All right. So this ground goes over to here. Beautiful. Okay, let's look at this area. This goes to here. This goes over to here. This should be black. This should be red. Okay, so this is going over to here. Okay, terminal 1. It doesn't really matter. They're not polarized, so it doesn't matter. The red to the red. This diode is facing this way, so this stripe is here, and cathode is here, anode is here. This goes to here. This goes over to the drain. And let's look over here. This is here. Okay, positive to positive, negative to negative. Let's look at our code. All right. Let's say if it's low. Let's try this. All right. All right, let's look at the code. So this is always going to be high, right? So if it's high, we want to write low to the motor pin, because it's always high. Look, if we get rid of this, let's just comment this out. Let's comment this out, and we'll do this instead. We'll say switch state. Okay, so if we run it, it's always on. So it's always going to be 1. If we click the button, it's 0. So we could say if the switch state is high, write low. If the switch state isn't high, it's low, write high. Okay? Now let's do one more. The only thing is it's always turning on. It shouldn't be on right now. It should be off. So let's see if we hook something up that's wrong. I'm going to pause the video for a second. I'm going to take a look and I'll tell you anything I found. All right, guys, so I figured out what was wrong. I'll explain to you how I figured it out and what we did wrong. So if we look at the one in the book,